Hello guys. So this channel is basically to help out with IGCSE Add Math. I would also do math as per anybody's request. But yeah, the channel is basically to help with questions that you may have with Add Math. I'm going to be going through different question papers. I'll go through the answers as well. But for now, each video is going to be like going through a question at a time because doing a whole paper is going to take a long time. Yeah, if you can, so because if you can understand the structure of each question that I go through, then I believe you can be able to do any paper at all. So, for those of you who don't know, my name is Somto Abraham, and well, this is my channel. Let's get started. So this first question says, on the axis, sketch the graph of y equals minus 1 over 5, x plus 2, 2x minus 1, x plus 5, stating the intercepts within the axis. So the first thing you would do for a question like this is to find the intercepts. Let's write out the equation again first. X plus 2, 2x minus 1, and then x plus 5. So you find the intercepts first. And intercepts meaning you find x when y is 0 and you find y when x is 0. So let's find the x-intercepts first. That means we would put y equals to 0. So if you rewrite this, you would have x plus 2, 2x minus 1, x plus 5 equals 0. Now you can multiply both sides by minus 5. That will take care of this right here. And this is just 0. So that goes away. So then you have x plus 2, 2x minus 1, x plus 5 equals 0. Now for each of these to be true, each bracket has to be equals to 0. So that means that your x equals minus 2, or x equals 1 over 2, or x equals minus 5. Those are your three x values. With this, you can even state it out here and say, so you found one intercept. You found your x, or your x-intercept. This is 1 over 2. This is minus 2, and this is minus 5. Now, you can find your y-intercepts. That means you're putting x equals to 0. So you would have minus 1 over 5, 0 plus 2, 2 times 0 minus 1, and 0 plus 5 equals to, well, that's y, because we are looking for what y is. So this is minus 1 over 5, 2 plus 2 is 2, this is minus 1, and this is 5. You can, 5 cancels 5, minus times minus is plus, so then your y is just 2, which means your y is here, 2. So now this is one part of the question. You still need to know how to sketch your graph, right? And we know that the graph crosses minus 5, minus 2, and 1 over 2. It also crosses this. So you need to know where the graph increases and decreases. Now to do that, you would find you take the first derivative. Now, which just means differentiate once. So to make that easier for us, we're going to multiply this out. We're going to multiply this out, right? And we're going to have, if you multiply this out, what do you get? So x, I'm going to leave the fraction for now. So this is 2x squared minus x plus 4x minus 2, x plus 5. Let's simplify this first. 2x squared, 4 minus 1 is 3, so this is 3x minus 2, then x plus 5. Now let's multiply out this. We're leaving the fraction for now. It's easier to work with whole numbers than fractions, so you can multiply out the fraction after you've expanded each of the brackets. Yeah, so this becomes, so now I'm multiplying this and this. This one's 2x cubed plus this, and this is 10. So plus 10x squared plus 3x squared plus 5 times 3 is 15, so 15x, then minus 2x minus 10. Right, now let's collect like terms. You have 2x cubed plus 13x squared plus 13x minus 10. Now you can multiply out the fraction to open up the whole bracket. So you would have minus 2 over 5 x cubed minus 13 over 5 x squared minus 13 over 5x minus, no, that's plus, yeah, plus 10 over 5 is 2, so plus 2. Now your first derivative, which is dy, you're finding y in terms of x once, so dy dx. I can just refresh your memory if you can't remember how to do that. So you have your coefficient, you have your unknown, and then you have a power. So to find the derivative of this in terms of x, you would multiply the power by the coefficient, and then you subtract 1 from the power. So that's basically what you're going to do for each of these. So this first one would be minus 2 over 5 times 3, which is minus 6 over 5, then x, then 3 minus 1 is 2, so 2. Next one is minus 13 over 5 times 2. 13 times 2 is 26, so minus 26 over 5x. Then this, because the power is 1, this is just 13 over 5, because 1 minus 1 is 0, so there's no exponent in that anymore. So now you found the first derivative. What you will now do is, if we had a little, I'm going to remove this so that we have space. If we had a little, almost like a number line, but this is with the x-intercepts. So this is minus 2 and this is minus 5. We need to know where the graph increases or decreases. So because the graph can go like this or it can go like this. Now we don't know which one is the correct graph because we need to find a sketch of the correct graph. So we're going to pick values between these intervals, and a value here, something less than minus 5. You can pick minus 6, something between minus 2 and minus 5, minus 3. We can use 0 for this, and we can use 1. So what you will now do is plug each of these x values that you found, that's minus 6, minus 3, 0, and 1, into this first derivative. And a good thing to note is if the first derivative, this sign or this notation basically means the first derivative of x. If the first derivative is greater than 0, then your graph increases. If it is less than 0, then your graph decreases. So with that, we can move forward and plug these x values in red. You can plug them into our first derivative function. So then you would have, if you are using x equals minus 6, you would have that. You can also plug this, if you have a calculator, just plug this into your calculator. It's faster to use. You would have that minus 6 over 5 times 6 squared minus 26 over 5 times minus 6 and minus 13 over 5. That would give us I'm sure some of you have already plugged this into your calculator. So if I simplify this, I have 36 here, and this minus times minus is plus, so this becomes 26 over 5 times 6 minus 13 over 5. So this will give us, I'm plugging this into my calculator, and I get minus 14.6. Now, I'm not worried, I'm not concerned about the actual value. I'm only concerned about the sign. Now, this sign, negative, means it is less than 0. So, and as per our rule here, if this first derivative is less than 0, then it decreases. Meaning, at this point, before minus 5, your graph is decreasing, so it's going down. So it goes down and then it crosses the x-axis as minus 5. Now, with your intuition, you can say, okay, if it goes down here, meaning it goes up here, it goes down here again, something like that. Now, while you'll be correct, not all graphs are like that. So you would want to actually test out each and every value of x. So we've gotten minus 6. Let's go to minus 3. Now you can just pause and do all this yourself. Minus 3. So you'd have, I'm going to copy this so I don't have to go back and forth. 1 second. Copy, paste. I'm going to paste this up here. Okay. So you'd have minus 6 over 5 minus 3 squared minus 26 over 5 minus 3 and minus 13 over 5. This would give you so minus 6 over 5. This is 9. 3 squared is 9, and this is plus 26 over 5 times 3 minus 13 over 5. This is a positive value, 2.2, or 11 over 5. Now, like I said, I am not concerned about the actual value. I'm only concerned about the sign here, which is positive. So which means here, before, that means at minus 3, the graph increases. So it's going to go down. It's going to come up. Because minus 3 is kind of somewhere here. She's going to go, is increasing at minus 3. So, which means it peaks before that. So, you're going to hit minus 2. And like I said, you can use your intuition, like we found before. We can use your intuition to say, this goes down and this goes up again. Right. Now, if you are wondering, well, how do you know maximum and minimum points? I think you can find that using, using second derivative. So you would differentiate this. You've differentiated this function once and you got this. You can differentiate it again. I think you can use that equation to find the maximum and your minimum points of the graph. Okay, for x equals 0, I mean, you can already see that for x equals 0, you would just have minus 13 over 5, because all this is going to be 0. Yeah, so you'd have a negative number, which means it decreases at that point. So we're right in saying here, here the graph decreases at this point. Okay, now we're just going to use this and test. Did I say increases? I meant decreases, my bad. We're going to use x equals 1 to test if after that, if we get, because here we put that at x equals 1, we put that it keeps on decreasing at x equals 1, so we can also check to see if we're correct. 26/5, 1 minus 13/5. This will give me minus 6/5, minus 26/5, and minus 13/5. Now this is 26 plus 6 is 32. 32 plus 13 is 45. So you are going to have minus 45/5, which is minus 9. So yes, it's negative, so it keeps on going down. So this is what your graph is going to look like. So if we go to the original question, now you need to remember that the graph also crosses y equals 2. So when you're drawing it, keep that in mind. So this would go down from here, it will go up, and then it's going to hit y equals 2, and it's going to go back down. It doesn't have to be pretty, but it's a sketch, and that's what they're looking for. It's a sketch. So that's for that. We can actually go to the mark scheme to see if we got it right. Whoops, you're not supposed to see that. Okay. Yeah. So this goes down, it goes up, it goes down again. So you have your x points, minus 5, minus 2, 1/2, and it has a cubic shape. As kind of has a cubic shape, but your drawing might be more accurate than mine. That's fine, but it's a sketch, so they're not looking for you to draw it like a graphing calculator would. Yeah, and then a point for marking y equals 2 on the y-axis. We got that as well. So yeah, let's go to B. So it says solve the inequality this greater than or equals to 0. So this is your graph. This is your graph, and we know that this graph is basically y equals this, which means that this greater than or equals to this 0 is pertaining to y. So they're asking you to find the areas or the intervals where the graph is greater than or equals to 0. And if you interpret that, where is y equals to 0 on this graph? Y equals 0 when y equals 0 on the x-axis. So they're asking you to basically find all the values or where the graph is above the x-axis. So you're looking for the interval here, that's this area here, and then this area. You can solve for this question. If you don't have the graph, you can actually solve for this question, but since we already have the graph, we don't have to solve for the question, and you want to save time, so, and it's only 2 marks anyways, so you don't have to do that much calculation. So from this, you can say when x is less than 5, that's when x is in this region, when x is less than or equals to, because remember the sign here is less than or equals to. So when x is less than or equals to minus 5, so less than, x less than or equals to minus 5. That's one part. And then this part is between minus 2 and 1/2. So you can say minus 2 is less than or equals to x, which is less than or equals to 1/2. And this is your answer to this question. Yeah. Okay. You can cross-check from the mark scheme to see if it's correct. Yeah. You have x less than or equals to minus 5, and then minus 2 less than or equals to x less than or equals to 1 over 2. So that is that. Yeah, I actually did post a video of this before, but I found out that it had no audio. So I'm going to keep on solving this paper in other videos so that you'll be able to refer to it if you have any issue. That is the end. Bye for now.